Put a metal spoon and a wooden spoon in the same room overnight. By morning, they've both been sitting in exactly the same air for hours. If you measured them carefully with a thermometer, they'd be almost exactly the same temperature. Now touch them. The wood feels fairly normal. The metal feels cold, not slightly different. Sometimes the metal can feel dramatically colder, which seems impossible. If temperature is what determines whether something feels hot or cold, and both objects are at the same temperature, then why does your hand insist that one of them is colder? The obvious guess is that maybe the metal actually is colder. But it isn't. So the real mystery is not what's happening inside the spoon, it's what's happening inside your hand. Because your skin is not a perfect thermometer. When you touch an object, your nervous system is not simply reading out its exact temperature like a digital sensor. What your body is much more sensitive to is something else. How quickly your skin is gaining or losing heat. And that small difference changes the whole story. Imagine the room is at 68 degrees Fahrenheit. The wooden spoon is at 68 degrees. The metal spoon is also at 68 degrees, but your hand is warmer. The surface of your skin might be somewhere around 86 degrees Fahrenheit, depending on the conditions. So the moment your finger touches either spoon, you have a warm object, your hand, touching a cooler object. And whenever two things at different temperatures come into contact, thermal energy tends to move from the warmer one to the cooler one. In this case, heat begins flowing out of your finger and into the spoon. Your skin loses energy, its temperature starts to fall, and the temperature-sensitive nerves in your skin detect that change. That cooling signal is sent to your brain, and your brain interprets it as, "This feels cold." So already, there's an important distinction. The sensation of cold is not simply your brain asking, "What temperature is this object?" It is also asking, "What is this object doing to my skin?" But that still leaves the main question. If the wood and metal are both at the same temperature, then heat should flow from your hand into both of them. So why does the metal make your skin cool so much faster? The answer lies in what happens to that heat after it enters the material. Let's start with the wood. The instant your finger touches it, heat begins moving from your warm skin into the cooler wooden surface. But wood is a poor thermal conductor. That means thermal energy does not move through it very easily. So most of the heat leaving your finger initially stays fairly close to the exact place you're touching. That small patch of wood begins warming up. And this matters, because heat flow depends strongly on the temperature difference. At first, your finger might be around 86 degrees while the wood is around 68. That's a fairly large difference, so heat flows out of your hand. But after a moment, the tiny patch of wood beneath your finger may have warmed up. Now that surface is closer to your skin temperature. The difference becomes smaller, so heat leaves your finger more slowly. In a sense, the wood quickly creates a little warm zone beneath your hand, and because wood does not carry that heat away very effectively, that warm zone stays there. Your finger is no longer in contact with something that behaves like a huge cold reservoir. It is touching a small patch that your own body has already partially warmed. Now compare that with metal. The beginning is exactly the same. Your warm finger touches the cooler metal. Heat flows from your finger into the surface. But now something very different happens. Metal conducts heat extremely well compared with wood. So the energy entering the surface doesn't just sit there. It rapidly spreads away from the contact point into the surrounding metal. The patch directly beneath your finger tries to warm up, but the metal keeps carrying that heat deeper into the spoon, which means the surface stays relatively cool, and because the surface stays cool, there continues to be a large temperature difference between your skin and the metal. So more heat leaves your hand, and then that heat gets carried away too, and more heat leaves, and more. Your finger is effectively connected to a much larger amount of cool material. That is why the metal feels colder. Not because the metal started at a lower temperature, but because it is much better at removing heat from your skin. You can picture it like trying to pour water into two different containers. Imagine the surface under your finger as a tiny cup. With wood, that cup fills quickly. Heat enters the surface, but because the energy cannot move away very easily, the local area warms up. Once it has warmed, it becomes harder for more heat to flow into it. With metal, it is as though that tiny cup has a large drain underneath. As soon as heat enters, it gets carried away. So the surface is constantly ready to absorb more energy from your hand. The analogy isn't perfect because heat isn't literally a liquid flowing through pipes, but it captures the important relationship. Wood lets the contact area warm up. Metal keeps spreading the energy away, and your skin can feel the difference. This is also why the phrase "metal feels colder" can be slightly misleading. What your nerves are really detecting is a faster drop in skin temperature. Your brain then turns that rate of cooling into a sensation. Fast heat loss feels very cold, slow heat loss feels less cold, and once you understand that, a lot of ordinary experiences suddenly make sense. Think about getting out of bed on a cool morning. Your foot touches a wooden floor. It may feel chilly. Then you step onto a tile floor. Suddenly, it feels freezing. You might instinctively assume that the tile must be colder than the wood. But if both have been in the same room for a long time, they can be at almost the same temperature. The difference is that tile usually conducts heat away from your foot much more effectively than wood, so your skin cools faster, and it feels colder. Now step onto a carpet in the same room. The carpet may feel warmer still. Again, the carpet does not necessarily have a higher temperature. Its fibers, and especially the air trapped between them, are poor conductors of heat, so they don't carry your body heat away very quickly. Your foot stays warmer, therefore the carpet feels warmer. Same room, similar temperatures. Completely different sensations. And there's an even better way to reveal what's really happening. Reverse the situation. Instead of putting the metal and wood in a cool room, imagine heating both of them until they are warmer than your skin. Let's say both are at 122 degrees Fahrenheit, now you touch them. Heat no longer flows out of your hand, it flows from the objects into your hand. So what happens? The metal feels hotter, sometimes much hotter. But notice what just happened. When both objects were colder than your hand, metal felt colder. When both objects are hotter than your hand, metal feels hotter. That seems strange until you realize the exact same property is causing both effects. Metal transfers heat quickly. When it is colder than you, it pulls energy out of your skin quickly, so it feels very cold. When it is hotter than you, it pushes energy into your skin quickly, so it feels very hot. Wood does both more slowly, so at the same measured temperature, wood often feels less extreme, and that gives us a useful clue about what feeling temperature really means. Your sense of hot and cold is partly a sense of heat transfer. It is not just about where the object is on the temperature scale, it is about how rapidly energy is moving between the object and your body. There is another subtle point here. You might wonder, if metal removes heat from my hand, doesn't that eventually make the metal warmer? Yes, absolutely. If you hold the metal spoon long enough, the part you're touching will gradually warm, and your hand will cool slightly. Eventually, the temperature difference becomes smaller, and the sensation becomes less intense. But at the beginning, metal is very effective at carrying the incoming heat away from the surface. So your skin keeps losing heat quickly. Wood reaches that locally warmed state much sooner. That is why the difference is strongest when you first touch the objects. There's also a reason metal is especially good at this. Inside a metal, thermal energy can spread efficiently through the material. Atoms in solids are constantly vibrating, and in metals, mobile electrons also help transport energy from one region to another. You do not need the microscopic details to understand the effect. The key point is simply that energy can move through metal much more easily than through wood. In wood, the structure is much less effective at passing thermal energy from one region to the next. Wood also contains tiny pockets of air, and air itself is a very poor thermal conductor. That is part of why materials containing trapped air are so useful as insulation. Think about a winter jacket. A good jacket doesn't generate heat. It doesn't somehow produce warmth from nothing. What it mainly does is slow down the rate at which your body loses heat to the environment. The trapped air inside the jacket is bad at conducting heat, so your body stays warm longer. In that sense, wood behaves a little more like insulation. Metal behaves more like a thermal highway, and now we can go back to the original mystery. A wooden spoon and a metal spoon sit next to each other all night. same room, same temperature. You touch the wood. Heat leaves your finger, but the surface quickly warms, and the material does a poor job of carrying that energy away. So your skin cools relatively slowly. Then you touch the metal. Heat leaves your finger again, but this time the material rapidly spreads that energy away from the contact point. The surface stays cooler. More heat keeps leaving your skin. Your skin temperature drops faster. Your nerves detect that faster cooling, and your brain says, "That is colder." But the metal was never actually colder than the wood. Your hand was responding to heat flow, not simply temperature. And that is the part that makes the whole thing click. Hot and cold are not just properties of the object you touch. The sensation is created by an interaction between the object and your body. Change the material, and you change how quickly heat moves. Change the direction of the heat flow, and the same metal that feels brutally cold can suddenly feel brutally hot. So the next time a metal railing feels freezing while a nearby piece of wood feels almost comfortable, remember, the thermometer isn't being fooled. You are not imagining the difference either. They really can be the same temperature. The metal just changes the temperature of your skin much faster. And what you experience as cold is your body feeling that heat disappear.